Hello and welcome to another Earth Science Podcast. I'm your host, Mr. Buss. Let's talk about the atmosphere and the greenhouse effect. Some sunlight that hits the Earth is reflected back to outer space. Some sunlight that hits the Earth becomes heat. Without an atmosphere or greenhouse gases, that heat goes right back out to outer space as well. But if that sunlight becomes heat and it contacts a greenhouse gas in the atmosphere, it can be directed back down to the surface of the planet. And then it's going to be trying to escape again, and it's going to hit a greenhouse gas and be directed back down to the surface of the planet, and so on. So that's the greenhouse effect. If light reflects, the greenhouse effect is not taken part. If light becomes heat and the heat escapes, the greenhouse effect has not happened. But if light becomes heat and then gets redirected back down to the planet, that's the greenhouse effect. Here are your major players in the greenhouse effect: carbon dioxide, methane, chlorofluorocarbons, ozone, and nitrous oxide. Alright, so what are greenhouse gases? On the left and on the right we have two different atmospheres. On the left we have 1, 2, 3, 4, 5, 6, 7, 8 greenhouse gas molecules, and on the right we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have twice as many in the atmosphere on the right than we do on the atmosphere on the left. So let's take a look at heat rays A, B, and C on the left and the right. So on the left, heat wave A contacts a greenhouse gas unsuccessfully and heads out to outer space. B doesn't contact any greenhouse gases and heads out to outer space. C does reflect off a greenhouse gas, carbon dioxide, nitrous oxide, something, and does successfully head back down to the Earth, where it then heads back out to outer space. So you did have a little bit of reflection of heat. On the right, wave A. This time, a double reflection and is sent back down to the Earth. Wave B, still unsuccessful. Wave C, also sent back down successfully and directed back down a second time. So you can just see the more greenhouse gases you have in the atmosphere, the more reflection you're going to have of heat back to the surface of the planet. I apologize again for the text not coming through very clear. Let's look at our greenhouse gases, specifically each one. Carbon dioxide, or CO2. Described as the most important greenhouse gas. Not that it's the most powerful, but it's actually just because it's more abundant than any other greenhouse gas. In the atmosphere you have nitrogen, you have oxygen, you have argon, and then you have CO2. It's only the fourth most abundant gas in the atmosphere, but it is the most abundant greenhouse gas in the atmosphere. So where does all that carbon dioxide come from? It's not very much to begin with. Remember, it's only 0.038%, I think, or something like that. But where does it all come from? Well, it comes from cellular respiration. As you breathe out, you're breathing out carbon dioxide. So animals and plants as well. I know a lot of times we think plants just give out oxygen. Well, when they burn the fuel that they make, they also breathe out carbon dioxide as well, interestingly enough. So cellular respiration. Volcanoes, huge emitters of CO2. And at the time, we haven't gotten into the history of the planet, but there was a time in our planet's history when it was ice ball Earth, and it's thought that plate tectonics and volcanic eruptions are what got us out of the ice ball planet at the time. When plant matter or animal matter dies, what happens to it? It decays. And bacteria and fungus are going to decay and basically do the same thing of cellular respiration that animals do. They're going to take that and they're going to send it back out to carbon in the atmosphere. And when we burn things, of course, we're sending carbon back down out in the atmosphere as well. So how do we get rid of carbon dioxide in the atmosphere? Well, it happens naturally. Oceans are a huge carbon sink. They can, obviously, as the atmosphere interacts with the ocean, carbon dioxide in the atmosphere will become carbon dioxide in the oceans, and so oceans will absorb and soak up the carbon, and as the oceans turn over, as surface waters sink into deep water, they will continue to absorb more and more carbon dioxide, actually acidifying the oceans as it becomes carbonic acid. Carbonate production in rocks. So rocks, these rocks are made of carbon. They are carbonate rocks, like limestones. and absorb. And talk briefly about how does that happen. How do you make these rocks? Well, think about how they're made. They're sedimentary rocks, right? And so sedimentary rocks are made out of sediment. So in the ocean, you had dying plankton and diatoms and animals, plants, and some of those animals, plants like diatoms might have had carbon in their bodies, shells, those types of things, and that can certainly become part of the rock structure. Think of coral reefs, coral animal that is able to make a carbonate shell, so to speak, or body, and those types of things also are going to become rocks in the bottoms of the oceans. And plants as well. These are redwoods, the west coast of North America here. It's awesome to walk through and just see these things. They're just massive, massive trees. Enjoyed walking through and seeing these. These, when we think about it, where does this mass of the tree come from? It comes from the air. So the tree itself is primarily composed of carbon compounds, and it is absorbing the carbon out of the atmosphere into the structure of the tree. Here's a couple more greenhouse gases. Methane, or CH4, comes from decomposition of plant material, biochemical reactions in stomachs, so cows' stomachs, and cows are releasing methane. Methane is considered 20 times as powerful as CO2. It's not the most important, quote-unquote, greenhouse gas because there's just more CO2, but it is a very powerful one to keep track of. Nitrous oxide. Fertilizers are a major emitter of nitrous oxide, and so the nitrogen is a huge problem here, and nitrous oxide 300 times as powerful as CO2, so extremely powerful greenhouse gas. Tropospheric ozone. We talk about ozone in the stratosphere, that's a good thing. Ozone in the troposphere, bad thing. As kind of a complex chemical reaction here, but as you emit nitrous oxides out of your exhaust here, and those combine with volatile organic compounds, you're going to have a net result of ozone in the troposphere, and that is a greenhouse gas as well. 1,000 times as powerful as CO2, but it does decay quickly. And then fluorinated gases. These are 100% artificial in nature, totally human-made, and not only are these greenhouse gases, but they are our major concern. They're destroying ozone in the stratosphere. So ozone, I'm talking about ozone twice here, bad, good. You want the ozone in the stratosphere. That's good stuff. Blocks out UV light. Thanks for joining me, and I'll see you next time.